Good morning. We know there are many three types of connections available for three-phase system. One is individual connections, second one is star or Y connections, and third one is delta connections. Now we are going to see star or Y connections. We have already seen that what is star connection, the basics of star connection in the previous slides. Star connection means here three phases are connected. Similar ends of three phases are connected to form a junction. That junction is called neutral. Okay. And from each three phases we can take the connections outside. Okay. Here, in a balanced three-phase star-connected system, RMS values of EMF generated in the three phases are ERN, EYN and EBN. That means EMF generated in phases are ERN, EYN and EBN. ERN means the voltage between R phase and neutral. EYN means voltage between Y phase and neutral. EBN means voltage between B phase and neutral. And this voltage is called phase voltages. The voltage between a line and neutral is called phase voltages. Similarly, here we can see other voltages VRY, VYB and VBR. VRY is a voltage between R and Y, which is called between two lines. The voltage between two lines is called line voltage. VYB is the voltage between the lines Y and B. So VYB is also called line voltage. Similarly, VBR is called line voltage. So here two types of voltage we have to study: phase voltage and line voltage. Phase voltage is a voltage between a line and neutral. Line voltage is a voltage between two lines. Now we are going to study the relationship between phase voltage and line voltage. For that, what we are doing is, we are taking a loop here. See, here, this one loop. Here, many loops are here. Here I am taking this loop. The loop consisting of ERN, EYN and VRY. Okay, ERN, EYN and VRY. This is a closed loop. I am taking that loop. ERN, EYN and VRY. Here Y is VRY. So here ERN, the polarity of ERN is like this. We have already studied double subscript notation. Double subscript notation means ERN means R is positive with respect to N. EYN means Y is positive with respect to N. So Y is here positive, N is negative. VRY means R is positive with respect to Y. Here you should write Y, VRY. This is VR. Okay. I am applying KVL in this loop. So, KVL in this loop, we know the KVL. Here, I am assuming a current in clockwise direction. Here, plus ERN, minus VRY, minus EYN. Okay. Plus ERN, minus VRY, minus EYN. So, VRY is equal to ERN minus EYN. Clear? Similarly, other two loops. Here it is like this. So similarly, we can take other loops. So we will get VYB equal to EYN minus EBN, VBR equal to EBN minus ERN. So here we are considering the phasor diagram. Phasor diagram means we know ERN here. ERN is a phase voltage, 120 degree apart EYN, 120 degree apart EBN. three phase voltages are 120 degree apart. Okay, then I have to find out VRY. VRY is a phasor sum of ERN and EYN. We know ERN is here. Okay, I should know what is minus EYN. It is a phasor sum of ERN and minus EYN. I should know what is minus EYN. I know EYN is here. So minus EYN is its opposite side. So the phasor sum of ERN and EYN is the diagonal of this parallelogram. So I can apply parallelogram law here. VRY is equal to square root of ERN square, square root of ERN square plus square root of EYN square plus 2 ERN into EYN into angle between these two, ERN and minus EYN. So we know ERN is E phase, EYN is E phase. So ERN equal to EYN equal to EYN equal to E phase. So I am substitute E phase here. 2 into E phase square. Angle between ERN and minus EYN is 60 degree because ERN and EBN is 120 degree. Then it is a bisector, so it will be 60. So we know VRY equal to root 3 E phase. Similarly, VYB equal to root 3 E phase, VBR equal to root 3 E phase. From this it is clear that VRY is the line voltage. Line voltage is equal to root 3 times phase voltage. See, in balanced 3-phase star connection, line voltage VL equal to root 3 times phase voltage. Line voltages are equal in magnitude but displaced 120 degree from one another. It is clear that VRY, VYB, VBR, 3 line voltages are 120 degree apart. Similarly, line voltages are 30 degree ahead of their respective phase voltage. See the phasor diagram. This is the phase voltage. ERN is the phase voltage. This is 30 degree line voltage. VRY is the line voltage. This line voltage is 30 degree ahead of this phase voltage. Similarly, the relationship between line current and phase current. See here, current. This is the phase current, current through the phase, IR. This is the current through line, IR. From this it is clear that line current and phase current are same current flowing through line and phase. So, in the case of star connected system, line current is equal to phase current. So, this is ERN, EYN, EBN, 120 degree apart. So, here in balanced 3-phase star connection, line current equal to phase current. Line current are equal in magnitude but displaced 120 degree from one another, IR, IY, IB. Angle between line current and corresponding line voltage is 30 plus 5, plus for lagging and minus for leading. This is ERN, IR. And the phase voltage and currents are 5 degree apart. So, line voltage and currents are 30 plus 5 apart. Power. Next, power in star connection. We know AC power in a single phase system is V phase into I phase into cos phi. So, 3-phase system is equal to 3 into power in single phase system, 3 into V phase into I phase into cos phi. Okay, we know phase voltage, the relationship between phase voltage and line voltage. VL equal to root 3 V phase. So, V phase equal to VL divided by root 3 into I phase equal to IL into cos phi. So, the power equal to root 3 VL IL cos phi. In balanced load, the neutral current is 0. How can we prove that? If we are having a balanced load is balanced, 3 phase loads are balanced, 3 phases same load are applied, the neutral current is 0. Neutral current IN equal to, see, this is a node, current is going outwards from this node and neutral current is coming inside. So IN equal to IR plus IY plus IB. IN equal to, we know, IM sin theta minus 120 degree, IM sin theta minus 240 degree, 120 degree apart. So solving this, we will get IN equal to IM into 0, that is equal to 0. Okay.